site of a fatal accident.
This tree is going to be struck again and again and again. This pole has obvious signs of vehicle impact.
We're at the location of a serious accident.
The driver lost control of the vehicle.
Mother and two small children.
Wrapped around this utility pole.
Left-hand guardrail that will steer a car.
Outdated as of 25 years ago.
Ridge columns right along the edge of the roadway on both sides.
Highway safety ought to be a priority.
The tendency is to put back what was there.
As a highway engineer, you should do anything you can to reduce the severity of an accident.
This location may seem harmless to drivers that use it every day, when in fact it can be deadly and is loaded with roadside hazards. For example, the large tree located just inches off the edge of the pavement. The utility pole on the outside of the curve. Moving down the road a bit, an unprotected guardrail end, which when struck can be deadly and penetrate into vehicles that lose control and come into contact with it. And over here is another large tree located just about 1.5 feet off the edge of the pavement, and in fact was the site of a fatal crash just last year.
Each year in the United States, we have a large number of deaths and serious injuries resulting from single vehicle crashes into roadside obstacles or roadside hazards. This has been a problem that's been with us for a long time, and it continues to be one of the leading causes of death and serious injury in this country.
Before about 1965, or around that period of time, the highway engineering profession's primary mission was to make a safe roadway. There was also the feeling that once you got off that roadway, you're on your own. It's up to you to get out of the perilous situation. It's their job to provide a good roadway and your job to stay on it. About in the late 60s, the philosophy changed to, if a vehicle goes off the roadway, as a highway engineer, you should do anything you can possible to either get them back on the roadway or reduce the severity of an accident.
We learned a lot in the early days of the interstate system, how to make these roadside features less hazardous. And so today, the modern interstate system exemplifies the designs that eliminate most serious roadside hazards. And since we've built many miles of interstate system in the United States, the problem has shifted somewhat. But we still have a very serious problem on the many miles of secondary road that are still out there.
The most dangerous roads we have now are rural secondary roads. They have the highest fatality rates. There's where you have very little opportunity to recover if you run off the road.
Almost half of all serious roadside hazard crashes occur on curves. Curves to the left are especially hazardous. Signs and pavement markings can help guide drivers around curves, but even where curves are well delineated, drivers can still lose control. And putting signs on roadside hazards isn't the answer. We need to do a lot more than that.
One of the major fixed objects along our roadsides, and the one that accounts for probably more fatalities than any other single fixed object, are trees.
This is an example of the most common problem in the area of roadside hazards, which is trees near the edge of the pavement, especially on curves. On this curve, there are trees right up against the edge of the pavement, and compounding the problem here is a complete lack of protection against drivers striking the trees. The trees are directly in line with any vehicle that loses control around that curve. After trees, utility poles are the most frequently struck object in fatal roadside hazard crashes. Every year in the United States, over 1,000 people die in crashes with utility poles. On this pole, you can see the marking and the scarring that's obvious. This pole has been hit many times and is located in a way that will guarantee it will be hit again in the future if it stays here. The way to deal with this problem is also obvious. Utility poles can be set much further back away from the road, creating a clear zone. Utility lines can be buried underground, eliminating the use of poles altogether. And the use of breakaway utility poles is an option. It's appropriate to remove isolated trees that are located in dangerous locations. However, trees and poles are often located in groups, and when this is the case, it's often more appropriate to shield those objects through the use of a safety barrier.
Guardrails are the most widely used type of safety barrier, but they're not used often enough to keep cars away from trees and poles. They're very effective, but if guardrails aren't installed properly, they can become hazards in their own right. One problem can be that while they're keeping cars away from one obstacle, they can direct them right into another.
This guardrail has been placed in such a way that while it provides adequate protection in some areas, it actually leads vehicles directly into the base of a very large tree, which is very dangerous. The way to correct the situation is to extend the guardrail past all objects on the side of the road and only end or terminate once there's a safe place to do so.
We have here a guardrail that's supposed to be protecting you against the bridge rail, but in actuality it runs you right into the bridge rail if you hit the guardrail. And as we can see, that bridge rail has been hit many, many times. The proper design is to have the guardrail out in front of this bridge rail and attached to it, such that you have a smooth transition from one to the other.
Another problem is the end of the guardrail itself, which can become a hazard if it isn't installed properly.
We're at the location of a serious accident with a mother and two small children that went off the left side of the roadway and hit this guardrail. This end treatment, which is like a knife edge, will impale a car, and that's what happened in this accident. The car hit the end of the guardrail, and it actually went up through the firewall into the passenger compartment of this car between two small children. This kind of guardrail is outdated as of 25 years ago, but still there's a lot of these around the country, thousands and thousands of them. Most modern guardrails have a type of end treatment that prevents the impalement of a car.
Burying the end of a guardrail can prevent impalement, but it's not the best answer because it can create a different hazard.
The solution to this problem is to make the post breakaway and make it essentially an energy attenuator.
This is one of the worst examples of roadside hazards that we've seen. Bridge piers like this one are often located very close to the edge of the pavement. They're especially deadly because of their large size and unyielding nature. At this site, a 36-year-old father of two small children died when his car veered off the road and struck an exposed bridge pier. We don't have to wait for somebody to die at a site like this to improve it. What we had at the site before was an exposed bridge pier that was extremely dangerous. Any vehicle running off the road coming into contact with that area of the bridge could result in devastating injuries. In place now is a properly designed guardrail that's attached to the exterior of the bridge pier. Along with that guardrail is a proper and safe end treatment that allows for a gradual deceleration of vehicles that run off the road.
Where bridge supports and other rigid structures can't be safely separated from traffic with guardrails, an alternative is energy-absorbing devices. Crash cushions and other devices can do an effective job of slowing vehicles down gradually. These concepts are simple. Wherever possible, provide a clear roadside that allows drivers a chance to regain control if they leave the road. If a clear zone isn't possible, make sure posts are designed to break away in a crash. And any remaining hazards should be separated from traffic by properly installed guardrails or other energy-absorbing barriers.
We at the federal level ran a highway safety improvement program. Under that program, we provided funds to the states to improve high accident locations. That turned out to be a very effective program.
Fixing roadside hazards is important because it can prevent a momentary loss of control or a minor crash from becoming serious or life-threatening. Engineering safer roads must become an even more important part of the national strategy to reduce deaths and injuries, now that speed limits and travel speeds have increased.
There are funds available for renovating and improving highways. It's very important that some of those funds be allocated to fixing the roadside hazard problem. Obviously, we can't fix them all at once. Therefore, it's very important for highway departments to have sensible priority schemes so that they can decide which ones they should fix first.
Roads are built by civil engineers, and civil engineers are civil servants, and they tend to do what the public wants. The only way you can get the state and local government to enhance safety on the roadway systems is for the public to want that enhanced safety. And I think they do.
Next time you're out on a country road, take a closer look. If you see hazards that shouldn't be there, especially on curves where loss of control is most common, ask yourself why. The answer is that for too long, solving this problem hasn't been a high enough priority. Raise the priority and help make safer roads.